Hey everybody, today I'm going to talk about how to make your own Ethernet cables. Building your own Ethernet cables can save you a ton of money in the times that you need new Ethernet cables, such as Cat5e cables, RJ45. A lot of times if you go to a retail store like Walmart, Staples, or places like that, you'll notice that the price of cables is usually exorbitantly high. Like for example, if you want like a 100-foot cable, they'd like to charge you like $75 for the cable. Yes, that's how much I've seen Ethernet cables, pre-made cables, go for. You know, commonly, let's say a 50-foot cable will set you back about probably $30. It's absolutely ridiculous prices. So I started making my own Ethernet cables. Not only is there the cost-saving advantage, you had the advantage of being able to repair cables that were previously not working. A lot of times the cable ends fail, and you can just replace the end on the cable and pretty much bring it right back to new state. So anyways, it's also a lot cheaper to buy RJ45 Cat5e cable in spools than to actually buy them pre-made. Now if you go to a place somewhere like Lowe's or a place like that, you'll probably be looking to spend maybe $60 to $80 for 1,000 feet. But if you're in the Charlotte, North Carolina area, there is a computer shop, a local computer shop called ATD Computers. They had this cable for like $45, I think. That's how much I paid for this. You can probably get it online as well for a similar price. So anyways, you'll need that. You'll need RJ45 connector ends. You see, I think this is a pack of 100. Yep, 100 pack. I think I paid maybe $5 to $10 for the pack. So, you know, let's just say 100 pieces, that's equivalent to 50 cables. So not too bad. And to actually build and crimp the cables, you'll need a cable crimper. This is an Ideal brand crimper. You can buy it at Lowe's. I think I paid $25 for it, somewhere in that area, maybe $30 tops. It can do RJ11 and RJ45. So if you're wanting to mess with phone cables, build your own phone cables, you can use this to crimp those as well. And it does come with some cable ends fresh out of the pack for both RJ45 and RJ11. So today I'm going to be making two relatively small size Cat5e cables. So just going to pull out just a little bit. Don't need too much. That should be enough about there. And what I'm going to do is unlock my tool and cut the cable. And we'll just put the remaining piece back into this little holding clip for the next time that I need cable. It'll be right there waiting for me. So here's a piece of cable. Yes, really small. It's just going from a 10100 switch to a back of a computer. It's right near on the same desk. Don't need a lot of cable for that. I figured using the small cable would be a good demonstration for this video. So basically there is a pinout you have to follow with Ethernet cables, which I'll show you shortly. First what we got to do is we got to remove some of this sleeving. So we'll put it through with the razor side up. You can see that there's a strip marking on the crimper tool. We're going to strip it right about here, and we just run this around several times, you know, back and forth all around the sleeve, because we're just trying to cut the sleeve, not the wires inside. And we just pull it around and it just pops right off. So nothing too much, pretty simple. And this cable, for some odd reason, it has this little string material. Not really sure why. Can't really complain. It is a you know, for the amount of money I spent on the cable, it's, you know, it's a good deal nonetheless. So we're just going to cut that little piece of stuff out of there. I'll just cut it down to size. Okay. So when you're doing standard Ethernet cables, which are non-crossover cables, there's a certain pinout you have to follow. Crossover cables, or more or less computer-to-computer cables, or device to device cables, follow a different wiring diagram, which I'm not going to show today. What you can do is you can probably look up online and get an actual diagram and just use that along with the demonstration here. So basically you have 4 twisted pairs. That's why it's called a twisted pair cable. This is an unshielded twisted pair cable, or UTP cable. So we're going to unspool these wires just a little bit. Get you a better focus on the wires. So as I mentioned, 4 twisted pairs. Now depending on the cable itself, it may be hard to build, maybe easy to build. This is kind of in the middle. Now I can't complain again due to the actual price of the cable. Let's unspool all of these. Pretty good bit. Okay, just a little bit more on this green and white green. Okay, so basically, let's take a look at a connector end so you can see sort of the visualization. Okay, this is the connector, clip side up. When you're looking down at this, or you can follow from left to right on the bottom side. There's your good view. From here to here, or clip side up from here to here. It is as follows: white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So again, it's white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. And the thing about this, especially where you start crossing up colors in the center, such as white, green, and blue, the twisted pairs like to fight you a little bit, so you have to be careful. So I'm going to go ahead and build this cable. Well, let's build this connector end. It's a matter of finding the best way to route that white-green end over to here. And once you get everything lined up to a half-decent manner, then you can shorten the wirings down just a little bit. So this thing acts like it's zoomed in, and it's not. Actually, I'm just going to pull that little piece of white string out of there. Since it's such a small cable, it can easily do so. So I'm going to trim these down just a bit. And the thing about these cables is when you crimp the cable, it's a good practice to not have these little wires hanging out and have your connector on the end. The connectors are purposely designed in a way that when you crimp them, it actually grabs hold of sleeving, which I'll show you better here shortly. Here's where things get a little tricky. Because these twisted pairs, they like to twist around and then go into the little slots the wrong way. And you want to make sure you have the wires, the actual wires themselves, as close to the end as possible. Okay, so that looks pretty good. Now let's take a look and make sure that our wires are correct. So we'll follow our our diagram. So white, orange, orange, white, green, blue. See, white, blue, green, white, brown, brown. This cable looks good. The wiring is in correct order. Clip up is how I looked at it. Just carefully make sure that the wires are in the correct order. The wires are in full enough. This looks very good. The wires are in to the end. The sleeving is up inside to where when you crimp the cable, the plastic will crimp down on the sleeving, giving you a more firm, secure crimp to the RJ45 cable. This way, if you pull on the cable by mistake, it won't tear up, the connection inside here. That's the purpose of that. Just double checking one more time. Because I don't actually have a cable tester. As long as you're certain that the connections are correct, you're safe to plug this into a device. I've never had any issues with that. So now that this cable end is ready to be crimped, we'll go ahead and crimp it. Just push it into this. Your crimp tool may be different. Once it's pushed in all the way, you squeeze on this and it crimps. Actually, I personally squeeze it twice, and you pull it out. This Ethernet cable is now crimped on this side, and we will just repeat the process for this side, and we would have a cable. As you can see, if you look carefully, you can see how you see a little plastic ridge inside of the connector. That's what I was referring to. When this crimps down, that pushes up and secures the sleeve. So that way, when you're pulling on this, it is nice and firm. Nothing to worry about. When you have the sleeve hanging out of the end, that's very insecure because the wires, the data wires are just hanging, and it's not very good practice. So we'll go ahead and do this to the other side, and I'll show you the end result. Okay, everybody, I have now put the end on the other side of this cable, so we now have a finished 2 foot long Cat 5e Ethernet cable. That's how it looks. The ends look nice and neat. Already been crimped. You just look carefully at the two and you'll see that the wires go all the way to the end like they're supposed to, and the sleeving is up inside of the connector, so no loose wires hanging out. Another thing to look into is before you put the cable into service, you'll make sure both wires, you look at the connectors carefully and make sure that the wires, the pinout is correct on both of them. Like, let's say if you get a wire backwards, you would hope that you got it backwards on both wires. Otherwise, you'd have to redo the whole cable, or at least redo one end. But the wires do match, so this cable is ready for service. So that is how you can create your own Ethernet cables. Save you a ton of money when you build them yourself. You can repair existing cables. You can cut bad spots out of existing cables and shorten them and make them good again. So anyways, if you guys have any questions or comments, feel free to ask them. Thanks for watching.